Web3's contribution to the decentralized AI data economy. Hello everyone, and welcome. Today, we're diving into a fascinating and rapidly evolving space, the convergence of Web3 and artificial intelligence. We're going to explore how Web3 technologies are not just impacting, but fundamentally reshaping the landscape of data and AI, moving us towards a more decentralized and user-centric future. This is an updated look at emerging technologies and future directions in what we're calling the decentralized AI data economy. We're at the cusp of a paradigm shift. For too long, data, the lifeblood of AI, has been concentrated in the hands of a few. But imagine a world where you have control over your data, where its value is shared more equitably, and where AI innovation is more open and accessible. This presentation explores exactly that. We'll see how Web3 technologies aren't just enabling a decentralized AI data economy. They're actively driving it, creating something truly transformative. We'll examine real-world examples, current trends, and what the future might hold, always with a critical eye on both the promise and the challenges. Now, let's talk about one. Data ownership and control. At its core, Web3 is about giving users true digital sovereignty. Think of it. You own your digital assets and, crucially, your data. This isn't just a philosophical idea, it's becoming a technical reality. We're seeing this implemented through self-sovereign identity solutions, using standards like decentralized identifiers, or DIDs. Platforms like Spruce ID and Veramo are putting the power of digital identity back in the hands of individuals. And then we have personal data vaults, secure digital spaces where you control access to your information. Projects like Solid and Inrupt are leading the way here. What does this mean in practice for data ownership and control? Firstly, granular permission control. You decide, specifically, who gets to use your data, especially for AI training. Secondly, transparent data lineage. Blockchain provides a clear, immutable record of how your data is used and who accessed it. And finally, monetization and revocation power. You have the option to benefit directly from contributing your data and, importantly, to take that access away. And this isn't just theory when we talk about data ownership and control. Recent developments are making this even more sophisticated. Networks like Ceramic are enabling composable data streams, meaning data can be shared in a much more flexible and granular way. And Lit Protocol brings decentralized access control to the table, so we're moving beyond simple yes or no data sharing to much more nuanced agreements. Building on data ownership, let's consider two. Decentralized data marketplaces. Imagine platforms that directly connect those who have data with those who need it, cutting out the traditional intermediaries. These are peer-to-peer marketplaces for data and even AI models themselves. Key components of decentralized data marketplaces here are smart contract-based licensing, automating data usage agreements transparently. Platforms like Ocean Protocol and Link-to-Fetch.ai are prime examples. Then there are tokenized data assets, representing data as unique, tradable digital tokens, proving provenance and usage rights within decentralized data marketplaces. And underpinning it all for decentralized data marketplaces is decentralized storage, using networks like IPFS, Filecoin, and Arweave to ensure data availability and resilience. The recent development in decentralized data marketplaces here is the expansion beyond simple data trading. Platforms like Ocean Protocol v4 and SingularityNet's NewNet are evolving into marketplaces for decentralized compute and AI services too. We're also seeing the emergence of specialized marketplaces focusing on niche AI applications, like medical imaging datasets or natural language datasets for specific industries. Think about it. These decentralized data marketplaces can source diverse datasets to tackle real-world problems, like improving fairness and reducing bias in facial recognition algorithms, a crucial step towards ethical AI. To fuel this decentralized data economy, we need the right economic engine, and that's where 3. Token-based incentives come in. We're talking about crypto-economic systems that align the interests of everyone involved: data providers, model builders, validators, and even compute providers, all through token rewards. These incentive structures within token-based incentives can take various forms. Quality-weighted data rewards mean you earn tokens based on the value of your data, not just the quantity. We're seeing projects exploring ways to actually verify and reward data quality within token-based incentives. Model improvement bounties incentivize community-driven model development as part of token-based incentives. Think of open challenges and rewards for making AI models better. Platforms like Numerai are pioneers in this space. Then we have validation and curation rewards as token-based incentives to ensure data and model quality, combating things like data poisoning. And finally, decentralized compute sharing compensates those who contribute their computing power to train AI models in a distributed way, another key aspect of token-based incentives. The cutting edge in token-based incentives here is the idea of reputation-based token distribution. Imagine earning more tokens for consistently providing high-quality data, building up a reputation that unlocks greater rewards. We're also seeing within token-based incentives the rise of NFT-based data licenses, offering much more sophisticated control over data usage and resale rights. Now, a critical aspect of this decentralized AI data economy is enhanced privacy and security. Web3 offers a toolbox of powerful technical approaches for enhanced privacy and security. Zero-knowledge proofs, or ZKPs, allow us to verify computations without revealing the data itself, essential for privacy-preserving AI and enhanced privacy and security. Federated learning is another key technique for enhanced privacy and security, where models are trained across decentralized devices, meaning the data stays put and the model comes to the data, minimizing centralization. This is often combined with Web3 for better incentives and data provenance within enhanced privacy and security. Then we have homomorphic encryption, allowing computation on encrypted data, although still computationally intensive but a part of enhanced privacy and security. And differential privacy techniques add statistical noise to datasets to protect individual privacy while still allowing for useful model training, contributing to enhanced privacy and security. The latest development in enhanced privacy and security is the combination of secure multi-party computation, or MPC, with blockchain verification. This is really exciting for enhanced privacy and security. It allows multiple parties to jointly compute something using their private data, but without revealing that data to each other, with blockchain ensuring the whole process is verifiable and trustworthy. We're seeing this being explored for sensitive applications like privacy-preserving credit scoring and fraud detection in decentralized finance, all falling under enhanced privacy and security. Moving on, let's discuss 5. Transparent governance. In traditional AI, governance is often opaque and centralized. Web3 offers a completely different model for transparent governance, decentralized decision-making. Think of DAOs, decentralized autonomous organizations, taking the reins of AI projects to achieve transparent governance. These are community-led organizations, ensuring broader participation and accountability within transparent governance. Governance mechanisms for transparent governance include AI-focused DAOs, like DClimate DAO for climate data or BioDAO for biotech data, demonstrating domain-specific governance. Governance tokens empower token holders to vote on important decisions, model parameters, data usage policies, even ethical guidelines, all aspects of transparent governance. And public auditing, using blockchain's transparency, allows for scrutiny of model training and performance, fostering trust and enabling transparent governance. Recent developments show AI DAOs are getting more sophisticated in transparent governance, moving beyond simple voting to things like quadratic voting, giving more weight to individual preferences, and delegative voting, allowing expert delegation. We're even seeing DAOs specifically focused on AI, ethics, and bias mitigation, acting as watchdogs and proposing improvements to ensure responsible AI development within decentralized ecosystems, contributing to transparent governance. However, we need to be realistic. Challenges in DAO participation and effective decentralized decision-making are still being actively worked on within the realm of transparent governance. This all leads to 6. Personalization and user-centric models. We're moving away from monolithic, one-size-fits-all AI towards AI that's tailored to you, controlled by you through personalization and user-centric models. Personalized AI means AI agents that adapt to your individual needs and preferences within personalization and user-centric models. This user empowerment through personalization and user-centric models comes through local model fine-tuning, using edge AI and on-device computation to personalize general models with your data, keeping it private. Frameworks like TensorFlow Lite and PyTorch Mobile are key enablers of personalization and user-centric models. User-owned AI agents means you control your own AI assistants, data analysts, and content curators, fostering true AI autonomy as part of personalization and user-centric models. And data unions are emerging within personalization and user-centric models, where users collectively pool their data to negotiate better terms or even build their own shared resources, increasing their bargaining power. The latest advancements in personalization and user-centric models regarding edge computing hardware and model compression are making sophisticated on-device AI personalization a real possibility. And the concept of composable AI is gaining traction within personalization and user-centric models, where you can assemble your own personalized AI agents by combining different decentralized AI services, creating truly user-centric AI experiences. Of course, this exciting vision also faces current challenges. Technically, when we talk about current challenges, we still have limitations. Blockchain scalability needs to improve for massive AI training. Coordinating decentralized compute is complex in the face of current challenges. User experience in Web3 can be daunting for the average user presenting current challenges. And verifying the performance and fairness of decentralized AI models is a novel challenge within current challenges. Market-wise, centralized data giants still have a huge advantage, a key market challenge. Regulatory uncertainty in different jurisdictions is a factor adding to market challenges. There's an education gap. Many people don't yet understand the benefits of decentralized AI, another market challenge. And bootstrapping these decentralized networks, getting them off the ground, is a classic chicken and egg problem, a significant market challenge. But the future is bright, and we see clear future directions. Technologically, in terms of future directions, expect Layer 2 scaling to improve marketplace efficiency. We'll likely see AI-optimized blockchains emerge, specifically designed for AI workloads as a future direction. User interfaces will become simpler and more user-friendly in future directions. And we'll see progress in formally verifying the quality and fairness of decentralized AI, a promising future direction. Ecosystem development is crucial for future directions. Look for industry-specific data unions and consortiums to grow as a part of ecosystem development for future directions. Cross-chain AI model and data registries will connect different platforms as an ecosystem development for future directions. Integration with traditional data brokers and enterprises will bridge the gap to the mainstream, another ecosystem development for future directions. And standardization efforts will help reduce fragmentation and promote interoperability in ecosystem development for future directions. In conclusion, Web3 isn't just a trend. It's a fundamental shift in how we structure data economies and develop AI. It's moving us from centralized control to distributed empowerment. This synergy between decentralized technologies and AI is unlocking incredible opportunities for collaborative innovation, all while prioritizing user privacy, control, and economic participation. This transition to user-owned data and models is a true democratization of AI, leading to a more equitable and innovative future. For researchers, developers, businesses, and policymakers, engaging with this paradigm is not just smart, it's essential to shape and benefit from the next wave of AI innovation, built on the principles of decentralization and user agency. Thank you. Finally, for references,